Hello, everyone. Thank you for tuning in to this episode of the Amazing Podcast. I'm Twain Taylor, editor at Amazing. And if you like this conversation, definitely go check out all of our stuff at amazic.com. That's amazic.com. We try to bring you the latest and greatest from the space of cloud computing, cloud native computing, Kubernetes, containers, DevOps. That's what we talk about most of the time. But I'm really excited today because we're going to be talking about something that, yeah, it involves the cloud, but it's quite different. I don't think we've ever had uh, an organization or a product like this feature on our podcast before, because they kind of blend hardware and software. And there's a couple of ways to describe it, but it's really cool. It's kind of like imagine. A cloud in a box. Imagine Kubernetes in a box, an actual physical hardware box, right, that you can actually hold, carry around somewhere, and yeah, yeah, you're looking at it right there on the screen. Imagine that. It's kind of like a Back to the Future cloud version that we're going to talk about today. You know, uh, Kind of going back a bit into the importance of hardware and then bringing it into the future of how it's going to blend hardware and software. That's what we're going to talk about. Anyway, enough said. I'm really excited, if you can't tell. But I have with me James Cabe, who is the Director of Architecture Global Alliances at ZPE Systems. That's the alphabets, Z, P, and E Systems. And they've got this product named Nodegrid, and it's really cool. I've never heard anything like this before, so I'm really excited to hear all about it, and I'm sure you will be too. James, thanks so much for joining us. It's great to have you with us on the show. Uh, to get us started, tell us a bit about yourself, your background, and how you got to ZPE Systems.
Thanks, Twain, for having me on. I really am thrilled and proud to be on your podcast today. So I really, really appreciate it. I go back a ways. I started my career at a small company called BBN Planet. And for all those that may have never heard of it before, it's the autonomous system one on the internet. So BBN was sort of like the first internet backbone company to ever exist. We were purchased by GTE Telephone, later became GTE Internetworking, and everybody will know who I'm talking about because our original DNS servers were 4.2.2.1. And I'm sure somebody, if they've been in networking for a long enough period of time, knows that IP address. So I started there. I've spent time in oil and gas. I've spent time in retail. I've spent time a lot of different places. I started my cybersecurity career at Fortinet, where I spent nearly a decade there, and I was a CTO of the Fabric Ready before I left to go work with a startup on industrial control system cybersecurity that got sold to Microsoft. So I had a turn at Microsoft as well. I got a call from one of my previous product managers at Fortinet that we worked together, and he called me over to ZPE and said, "You're really going to think this is the coolest thing ever, James. Come on over and take a look." And so here I am. And yes, I still think it's really cool. I've been here 2 years now, so excited to tell everybody about it. I think this is one of those things where people don't know what they're missing until they hear about it. So I appreciate you having us on, Twain.
All right, yeah, really excited to get started about this. So I want to start with just talking about data centers versus the cloud, because there's this popular story that, everyone is on the cloud now, that data centers are old school. Nobody runs anything on them anymore. Nobody needs a data center. All of the data center vendors, the co-locators, they're all going out of business. So we're in that world now where data centers are irrelevant. That's kind of the popular story. But from seeing just your product and what ZPE is doing, it seems like data centers are very much alive and well. Could you tell us a bit about that?
It's great, great segue. Thank you. So it's probably best to start where ZPE started. And we had a cloud company, Google, go to our founders and say, we have this management issue. We need to be able to manage stuff without a human going to go touch them. We need to be able to manage them at a distance. And the only way we know how to do this with commodity style computers is serial connections, right? And so at the time, our founders worked for a serial connection company that managed mostly routers and switches, networking equipment for very, very large carriers. Um, and they said, hey, we like this, but we want it to do this, this, and this. We want it to look like a cloud, right? But we want it to do things that are physical as well. And our founder said, well, that's really interesting. We thought about doing this before. Let's present what we were thinking about and see if it lines up. Well, their visions kind of came together and created Nodegrid as the platform. And so those physical data centers definitely still matter, but not necessarily to most enterprise or small business people. They ingest the cloud. The people where data centers matter the most still right now is your big cloud providers. So our company does a lot with a lot of hyperscalers and really interesting things like in a warehouse, we help them provide the stack that goes in that controls all their robots, which does all their picking systems. When they go deploy something, because the warehouse may not have an internet connection. So the Nodegrid has dual 5G, as a card that you can insert into it. And all of a sudden you've got internet connectivity over 5G that you can backhaul and get all your automation to be able to program the robots even before the warehouse has internet connectivity. So it's just interesting things like that have bled from the cloud, in the data center. And then we see compute going way more towards the edge now. The big problem with edge stuff is the fact that you have to now go back the old way and touch it again, right? So what we're trying to do is provide that cloud experience again to people that have physical stuff on premise or out in the field, construction trailers, oil well heads, shipping containers, people that have robots. Like one of our big customers is one of these automated car companies that the car has got AI and it runs without a driver. Well, how do you service the software when the software dies or the network goes away for those cars? We provide the box that makes that, fixes the network, fixes all the things that make sure you don't have to go from your chair where you're used to playing with the cloud all the time out to that edge to go make that edge thing work again. It just, oh, I can go click in the cloud and get back to my edge box, and it works because I've got a Nodegrid installed out there and I don't have to go in and touch it. So
Mhm.
it's really where this kind of boils in.
All right, all right. Yeah, those are some really cool use cases. And I think even later on in the conversation, we even probably going to be touching on a few AI use cases that have come up. So definitely a lot that needs hardware. And one of the things with hardware is that downtime is kind of a given. And so I see that the focus of ZP is resilience, and you talk about resilient system. So to get us started talking about resilience, if you could first uh, give us give us an idea of what are the main causes of downtime in hardware systems, because sometimes it's hard to imagine why those things happen, but knowing that this percentage is caused by this and that percentage is caused by that kind of helps put it in a bucket and understand it better. So what do you think? What are the main causes?
That's a great question. So you know, everybody likes to talk about cyber because it's a very sexy topic, right? But in reality, maybe only 20% of people's problems, and sometimes very less than that cause outages, that cause downtime, that cause people to lose money in their business is actually cyber related, right? 80% are human mistakes. And we saw this with big antivirus companies recently, right? There's a big problem there. Power systems. In Houston, I live here, and we had a hurricane, and part of the problem was the fact that they couldn't manage things at a distance. They had to take trucks to roll out there because the cell towers weren't working, or there's a bunch of problems, right? So
Mhm.
that whole piece, 80% of all the problems are really just this physical human mistakes, disasters, physical issues, fiber cuts, some silly person with a backhoe or big truck that backs into the wrong thing, right? That these are the problems that people have on a daily basis. So you definitely have to have something if you want to be resilient that applies to both, right? The 80% of the physical and mistakes and silly stuff people do, and the 20% where you have malicious actors for cybersecurity. And if it doesn't encompass the whole thing, you can end up with a lot of problems, right? So a great question. Great question.
All right, all right. So I want to ask a bit more about just defining this term resilience system. How do you see it? How does ZPE understand it? What is a resilience system? And for someone that's listening to this who thinks like, hey, that's a new term. I've heard about resilience, but what's a resilience system? How would you explain it?
So this is something that has been missing, and that's the reason why nobody's heard of it, is because everybody's so focused on things like, oh, prevention, like cybersecurity, right? They don't really, they're like, oh, only if the thing fails do we have to go into recovery. And then I always ask them, okay, great, what's your recovery? Well, some of the cloud companies, and I don't mean all of them, some of the cloud companies have very good responses for this, right? We have Kubernetes, we we even attack our own systems to make sure that things move around and that they stay up no matter what happens, whether we have database failures, network failures, or attacks, by other, by malicious actors. But there, there is this idea that not everything's a cloud, and even the cloud companies have their own data centers. So how do you manage stuff? Well, most people, and this may be the practitioners, your very technical people will just nod their heads and say, oh yeah, that's what we have. The management may be very surprised to hear the core management of everybody's infrastructure, whether it be digital or physical, is usually something called a jump box. And a jump box, whether you call it a jump box, whether you call it a bastion host, whether you call it a management workstation, all of those things are all the same thing, right? It's all, I had to put a small computer out there and I have to have remote access to it to manage it, right? So this, by the way, is the smallest Nodegrid we have. We have some that range very, very far up in size, but this is one of the industrial ones that we could put on a wellhead somewhere. For me, it would be in West Texas, right, or open to Oklahoma. The
What's actually inside the box, if you could, or maybe you want to finish this and tell us a bit about it. You
this
want
is
to,
the least capable, but one of the cooler boxes that we actually have, actually. So in here, we actually have a serial cable that comes out and can go to other firewalls and routers, right? We have 4G LTE in here, and some of the one that's coming is going to have 5G in it. It's got a full 8-core Intel CPU in it, right? That has, this one only has 8 gigs of RAM that I'm holding in my hand. We do have some that go up to 16, just for this model. Other ones we have that go up to 64 gig of RAM and 2 terabytes of disk. And then we even have Wi-Fi on this one, right? And you say, oh, what do it's weird. Why do you have all these different? It's really just to manage these things. So the Wi-Fi even itself is meant to go out and attach to other Wi-Fi or measure other Wi-Fi to see if it's actually working, right? Not necessarily to provide access to other people. It can be turned into that mode, but the primary mode is, hey, is there something out there? Wi-Fi, is it working correctly? So we work very closely with Cisco Thousand Eyes to be able to provide some of that data, back into their systems that manage and tell you the performance of things. Because the other way to become more resilient isn't to prevent or recover. It's also, you've got to measure performance, because you're a little less resilient when things do not work as well as they're supposed to, right? You have more complaints, people don't get as much work done. So there's really 3 factors to that resilient systems: performance management, or just the idea behind, being able to track and fix performance issues, outages, caused by the physical and the mistakes, and then, the cyber pieces where maybe we get attacked and we lose all of our access to all of our systems. Can you go re-image those like that, right? No, I have to go send somebody out there with a laptop. No, you shouldn't have to do any of that. We should be able to push a button, have the machines reboot, all of them, in your office site or wherever you have it, and then have them re-imaged, get all their data back down and backed up, and then back up and working within an hour or two with nobody ever having to deploy out to the location, right? So those are all the things. Most jump boxes are only capable of a very small portion of what I just said. And when you deploy them, they're not secure, right? I have to then track the USB interfaces on this. I have to then, see if someone's unplugging the network. Well, that's the reason why we include something called the ZPE cloud that tracks something called immutability of the box, right? So there's an idea behind, like you said, a software and hardware mix that make this thing fully what it is. And in this particular case, I'm trying to find the share button. I'm so
Mm.
sorry.
No,
Uh,
sorry.
my eyes are getting old, past 50 this past year, and all of a sudden I
Oh,
can't see anymore. So I'm trying to
yeah,
get
you
used to
don't
the
look at it at all. Don't worry.
I'm trying to get used to progressives. So if you
Sorry.
can manage this stuff from anywhere, in other words, if it goes and checks in, this little device gets mailed out to somewhere, you plug in the power, and uh, you know, how do you get to it? Well, that's what ZPE Cloud is really for. You jump into it, you can see on the GPS where it physically got booted up. You can run scans on it from anywhere in the world to make sure that nothing's been changed on the box. Nobody's tried to break into it physically or hack it. All these things are kind of built into the cloud to see that what you're delivering on site is exactly what you sent out. Because one of the big problems that the cloud manufacturers had is that, disks weren't encrypted. They had, the jump boxes were very vulnerable themselves. If someone got a hold of them and knew which box to get when it's shipping, they could put viruses on their network before their network even starts up. So you have to be able to take all those things into account, and then also be able to go out and reach, things like power bars. Can I turn power things on and off directly from here? Yes, I can actually turn on and off the power to a power bar directly from the cloud, right? I can reach into the console of a Cisco, router even before it's got network configuration. I can reach into it and click on it and then get into the console of it right here on the cloud. So basically, it's like you said, it's a mixture of software and hardware. It's not just about the jump box anymore. It's about the management of it as an entire fleet, and then even being able to do the physical things at a distance. And this bleeds into that AI discussion you had. We even have units that have an NVIDIA, and this is brand new, the Jetson Nano, which is the newer version of their Tegra system. And Tegra is
Mhm.
older. This is the Nanos. So the Jetson Nano is the newest one. We put that actually in a little bit larger Nodegrid, right? That also has an 8-core, 64 gig of RAM box, but dual cellular. It has an AI card in it, and you manage that AI card at a distance. Lots of people wanted to deploy these Jetson boxes, a lot of places to get AI for video, to see if doors open or close, to measure temperature and HVAC. There's a lot of different reasons to use AI, right? And get that result back that you want to
Mhm.
see. It's a different thing to be able to manage all those boxes at a distance. So we put the Jetson directly into our box, and now we can do whatever you want. You load up the NVIDIA NIM, which is their application store, and they can deploy any kind of AI on our box you want. You have your version of AI you want to load. You bring up a container on our unit. You run it against the Jetson compute module, and all of a sudden you've got an AI system, whichever one you want to deploy at the edge. So it's a how do I get this done? Well, we're sort of the Leatherman. So everybody knows Swiss Army knives, but I think Swiss Army knives aren't very good. Victorinox, I'm sorry, but we have one called the Leatherman tool here in America, and it's a solid piece of kit, and I think of our system as a little bit more like that.
All right. Yeah, I gotta check that out. I haven't heard of that one. Uh, there's a term that I was seeing on your website, Gen 3 out of band management. Could you
Mhm.
talk a bit about that? What is out of band management and what's new with Gen 3 and why is it important to resilience?
That's so good question. I will get go back to what our founders had. So serial connectivity is a very special port in a router or switch device that's called a console, and that is the thing you can program a router or switch before the network, right? In other words, you plug in, maybe you have a laptop, maybe you have a blue cable. Hold on a second. I think I have one right here. It usually requires something that looks a lot like this cable right here, right? So, and you might have to plug it into a laptop or desktop and then program the router or switch at a distance.
Not
So
a regular Ethernet cable, is it?
not a regular Ethernet cable, as you can see. Now it looks because it's got an RJ45 jack, it looks like Ethernet, but
Okay.
this has a serial modem in it, or a
Oh,
UART, right? That then plugs in
oh,
your USB. And then this is not network. This is something called serial, which is maybe like your old dial-up modem, is the same sorts of protocols pass
hello.
over this to be able to get to those other devices. So
Mm.
the serial is the thing that you can reach those boxes before the network comes up to build the network, right? Before they even come up. And so uh, big carriers, like your Vodafones and your Orange and your Singtels and all those other companies, they have to have these gigantic networks with all these routers and switches. Well, they manage them usually through something called out of band. And out of band is just a bunch of these serial cables in a single box that goes out. And so that was the kernel or the nugget of the Nodegrid platform. That idea behind, I want to be able to do things before I even have a network. I want to automate them before my network is even there. And so that's where the idea behind Gen 3 out of band came, because Generation 2, Gen 1 was just those serial console cables from a box that had maybe have an Ethernet cable in it. You would then Telnet or SSH into that box and then be able to reach all your routers and switches that are connected to that box. The second generation was, oh, I'm going to put networking in that box, maybe a cellular modem in that box, and then I'm going to put a graphical user interface in the box so I can do things, right? Bounce around, see how things are work, create manage devices. I want to do an iDRAC or an ILO and then get into those boxes. That's really generation 2. Be able to get to your power distribution units, your plugs, and then manage those. That's really generation 2 of out of band. Generation 3 is this idea behind blending all this into a microservices architecture, giving it an even greater networking ability with all the overlay technology that we're used to from things people call SD-WAN, right? All the
Mhm.
overlay connectivity people are used to in virtualized networking, and then be able to bleed all the virtualized networking, the virtualization, including containers and full VMs, all into a single platform. And everybody's like, oh, well, wait, can't they just take the place of all my infrastructure? It's not really built to do that. You could, but it's more built to manage and operate all the things you currently have at a distance, not forklift it and get rid of what you have, but be able to provide this cloud-like management layer to even all your physical stuff that you have on-prem.
Mhm, mhm. Wow, interesting. So, when we talk about like resilience, one thing that is frequently talked about in the cloud and Kubernetes circles is just chaos engineering. And so, obviously Netflix, made this concept popular with their open source tools. Could you talk a bit about that and how that ties into the story of resilient systems?
Absolutely. So I don't know if I have applications turned on this particular unit. I might have to get into it. Oh, it does, right? So if you wanted to go get a Docker container and bring it up, usually that's not very easy. I mean, unless you've got Kubernetes, right? You want to bring it into, got to create a Helm file that talks to the cluster and it does. Now, there's companies out there that make this stuff very easy to do, and we partner with them. Portainer is a fantastic company that does Kubernetes management from the top. Neil is a fantastic CEO, love the guy to death.
I don't know the
We work
show.
together with him to blend Portainer to manage our units from the top, but not just deploy Docker containers on our boxes, but also to provide the scripting bits that go down, because you may have your own automation core and you want to turn it into containers. Well, you can then do that very easily, from our box and have your version of management even reaching down to the serial, right? So we work with Portainer and we do a bunch of other, things to be able to provide the at least hosting of the containers Or maybe you have a virtual machine, you need to load here, for different, your own jump box that you have, that you've worked on, maybe it's Windows, maybe it's Linux, and then you want to be able to run that from a single platform that that can automate all of it. And then you have to blend that together, and you'll see here through some sort of central management, preferably some sort of open source, some sort of open source, platform for automation. So Salt, Ansible, we actually build that directly into the device. So you can actually run Ansible and Salt directly from here, and then be able to automate all the things that you actually have throughout your core infrastructure. Because it's one thing to have Kubernetes, it's a completely different thing to have the automation and scripting and scheduling all built on the top of it. And here you'll see that we actually do that. And so we don't want to take that top level, top cop is what they call it, to do it. We want to be the thing outside of that. When you lose access to the top cop that you're currently using, when you screw it up, when you mess up BGP, DHCP, DNS, and everybody does once in a while, how do I go back and fix that, right? If I send out a very bad antivirus update and my whole system goes down, how do I recover? Well, I can put together a playbook in Ansible that will actually go out and then start up, go to the Nodegrid, start up Pixie service, deploy down from the cloud a image that you have for your golden image for your laptops, reboot them. It can at the same time go check and see if there's backups for everything and give you a nice report of, yeah, don't re-image these yet. We're gonna have to run a backup of them or try to remediate them some other way. But all the rest of these we have current backups for, re-image them right now, get them back up and working. And so that automated infrastructure, automated system is all the things you can build in. So it's not, hey, this thing does this one thing really, really great. It's the idea of a concept of bringing a bunch of things together. And the idea, have you heard of the term emergence before?
No.
The human brain is actually a product of something called emergence, right? We're not a worm, because worms only really have one part of their brain, and that's the one that makes them breathe and chew and do all the things that worms do, right? You had to have, memory sections, you had to have a speech section, you had to have all these things that the brain developed into it. It's all the different pieces of the brain that make it the human brain, that give us this idea behind consciousness compared to some other things, some other people like to say less evolved. We're all about the same evolution, right? We just evolved in a different way. So when we evolved, we then developed something called consciousness. Well, that's an emergence because you put a bunch of things together, and the whole is greater than the sum of its parts, right? And so when you take our system, it's emergently different because it does bleed the cloud and the physical together to be able to deliver stuff even for the cloud company. So even they use us, quite a few of them, the top of the top three use us right now to help manage many portions of their infrastructure, sometimes their entire data centers.
Wow. Amazing. I like how you describe that, you want to be not the top cop managing the entire system, but you want to be the guy outside that is there when things go wrong and can get you access to your system when it's not working, when it's down. So that's a really good explanation. And that kind of makes me think about, in that case, when we're talking about like everything, like there's an emergency and like a big part of the system has gone down. Obviously, you can't get the entire system back. How do you design it so that you have the right things, that are backed up, or the right things that are running on ZPE that can be turned on at any time, even if a big part of the rest of the system is down? How do you kind of design that whole thing, prioritizing?
That's wow. So I wish I had more time. We might have to do another one of these again.
Yeah, we're running out of time.
um, so I have actually created something called an isolated recovery environment. I gave this talk at Saint Con, and that's a cybersecurity, but for Blue Team in Utah. It's actually one of the best cybersecurity conferences I go to all year long. So here's a shout out to DC 801 and the crew that runs Saint Con out there. Mwah, chef's kiss. Y'all do a great job. But I gave this talk there because that was a great question. Everybody needs a little bit of something else, right? Everybody knows what the minimum level of their systems they need running to get them back operational, to have people start working again. And that is called a minimum viable operating paradigm, or MPOP, right? So that whole thing is what everybody has to go through, that exercise, right? That's the very first thing when I tell people you're not ready, they have a disaster recovery plan, and I look at it, I'm like, you're not ready for this. You're not ready for a disaster, because you
Mhm.
don't even have a minimum viable operating paradigm. There's nothing there, or
Mhm.
operating model. There's a whole bunch of different ways to put that, but one's literally MVP poo. I don't really want to get into it. Anyways, the acronyms there's a lot of acronyms for it, but the minimum product that you need to be able to operate your business or operate your service, everybody knows what, all the really good systems administrators and management know exactly what that is. To be able to recover from it, you really have to tabletop and know that what you've set up answers the question, what's your minimum viable operating, paradigm, right? And so I said, you could do it all with open source if you want to. You don't have to go buy product for it. You can do everything you need right here, right? And that's get things re-imaged, get the network equipment back up again, recover from everything, from all the way from a disaster that just wipes the whole thing away, all the way up to, Chuck made that DNS change, and all of a sudden now we can't get into anything. We can't get into our, badge systems to get into the data center. We can't, so we have to bust in a wall. No, you don't have to bust in a wall. You got a ZPE in there. We'll fix it for you, right? Like, that's the whole idea, is that it's something that exists outside of your current infrastructure to be able to manage it and recover it if in case you do something silly and create the problem for yourself. Because we all do. We're all human. We're fallible. But that's also what makes us really, really interesting and different than the computers, right?
Mhm. Wow, really interesting. I think we should definitely come back for a part two of that whole thing. Uh, what's the term again? Minimum viable
Operating model.
operating model. Okay, well, we should talk about that next time. Um, we're winding down. I want to talk about this idea of cloud repatriation. And because
Yeah,
that's something that has come up a lot in recent conversations, there's many organizations that are very interested in running their own system, not and taking it back from the cloud because of, skyrocketing cloud bills and just wanting more control. So I think this is actually really relevant to those kind of organizations that may not fall into one of the categories that you mentioned earlier, the telecoms or the oil and gas companies and all of those, but just regular organizations that want more control, want to save on costs. Have you seen organizations like that come to you more and say, we've been running our own hardware and we have these issues. We think you could help us. Have you seen more of those stories come up, and can you share a bit more about that?
absolutely. Um, where I've seen this is people go take a look for AI instances in the cloud, and they're like, what? How much does this cost? And we've noticed this because our parent company actually just helped Elon Musk bring up his big supercomputer that's AI, right? I think he calls it Grok, right? Um, they could not build the data center without our parent company, Legrand, because Legrand handles these power systems that are super dense, right? They, can do almost a megawatt for in a single page, right? And that's what's required to do AI. So AI density is extremely expensive, and it usually requires a lot more electricity and power, and that makes it so much more expensive, even for the cloud companies. If you want to get into AI, and I don't mean just ordering something silly like this, right? So it's a rabbit. It's one of those rabbits. I barely touched the thing because I tried it out I have a ton of gadgets. I like trying everything out.
Mhm.
Um, but if you're doing real AI, like I mentioned earlier with like video, or you're measuring and trying to use AI to come up with something, that compute is hot and expensive on power and all kinds of space and cooling. The clouds charge for that. So what I've seen it mostly in is people that are starting AI, they look at the cloud and they say, man, we could build that for a tenth of the price here. We're just going to put a cluster here, right? But they then cringe because they think that they still have to manage it in the old way that everybody manages things. Right? So they don't get the cloud anymore. Well, that's not true. Not if they talk to us. So yes, we've seen a lot more of it. More as AI has become a thing because people have actually been repatriating that because of price. They don't know where they're leaking their IP to. The problem is when you use these other models that are, either open source or free or even, you paid for, you're losing your intellectual property to those companies. And I've seen that over and over again where people are like, I don't want to help somebody big build their model because I do my thing that I do very well. 5 years down the line, if I give all my intellectual property to them, they're going to come in and do what I do automated, like, and get rid of me. So whereas, if I'm not building that intellectual property and keeping it within my own house, I'm doing it wrong, especially when it comes to AI. That's the thing. And then we've noticed that more and more and more as people understand AI better, the aha moment comes on and says, if I send my data up there, bad things may happen to me 5 years down the road. It may not be right now, but it could be 5 years down the road. So we've noticed more and more and more of this. So it's power, it's intellectual property and repatriation. It's a bunch of things. There's a bunch of moving factors, probably too many to name here, Twain, but we could even have another whole show over just, AI and what what the considerations should be for that. But we've seen a lot of it. And it ranges from silly physical things like power all the way down to, something like, I don't want to send out our special formula that does this, that makes this kind of medicine or does this kind of thing, to the AI companies because I don't know what they're going to do with that data.
Got it, got it. Wow, that's really interesting. Uh, yeah, maybe last question I could ask you as we finish is just as you look ahead the next year or two, what are some things that you're keeping an eye on? You kind of probably gave us hints already in many of your responses, but anything you'd like to wind down with, what do you keep, what excites you? Because you're in this space and you really seems like you're on the edge, so in the cutting edge of
No, no,
things.
no, no pun intended, right? So edge makes me extremely excited, right? Especially the application of AI at the edge is extremely exciting for me. I've played with it for a very long time. I even played with it back at Fortinet, if you could believe it. I have some very good friends that even started their own startups. Shout out to Paolo DeProdi and Priam AI and some of those guys that are out there. They originally started some of the original Chat GPT stuff that was at Microsoft and they're friends of mine because it was Microsoft Tay, which was a disaster before it was Chat GPT, which was really, really cool for people to use. Sometimes technology is a big mess before it becomes really cool to use. And I think we see the beginnings of a lot of that, not just on the AI side, but just on the next version of what cloud's going to be. Because I don't think in the next generation of all this stuff, the on-prem stuff will look a whole lot like the cloud will. And as people progress into those that, transforming what they're used to on-prem into more of a cloud-like experience, I think it's going to generate some very, very interesting changes for everything. The way robots work, the way, our own computers work as a networked thing. Scott McNeely, I threw out a quote from, and it wasn't Andreessen, it was gentleman, yeah, I think it might have been Andreessen that I threw out the quote about earlier. It's this the sum of the parts, right? So, but getting back into it, Scott McNeely with Sun Microsystems, where I was working at my first job at BBN, made this famous quote that the network is the computer. And I think we didn't know, he was very way ahead of his time. And we are way ahead of where we didn't even know what that meant. That was so far ahead. We were like, oh, that's silly. Of course, the computers are all in the network, so the network is a computer. That's cute. But I think we're going to realize later on that it had a very different meaning and that he was very far forward looking, that the networked stuff is going to create something very different than what we're used to. So I'm excited to see what's coming up. But with every bit of excitement also comes a little bit of fear. So I want to have my idea that I can have my own little happy island and be able to run my business and make money and feed my kids if everything else goes wrong or weird. So I'm still into resilient systems for a little while longer. So
Yeah, it's an awesome end to a fascinating conversation. Before you go though, James, just want to ask you about yourself. Just one more question. What would be your alternate career if not for your job in tech?
that's a great question. I'd probably go cut trees down for a living because I joke a little bit of joking. I actually like getting my hands dirty. Recently, we had a hurricane here in Houston, and I have a big 21-inch chainsaw because I'm just that guy, that always has. I'm the neighbor that has the chainsaw. I'm the neighbor that has the truck because, of course,
Mhm.
I have a Ford F-150. Not to name brands or anything, but
Mhm.
anyways, I recently got rid of the gasoline chainsaw. I was tired of fixing it all the time. I went out and got myself an electric chainsaw, and I'm in love with it. I love
Mhm.
the battery powered chainsaw. So I've even convinced my brother, who was making fun of my electric chainsaw. He held it for a little while. The next day went to go buy his own battery powered chainsaw. So we're I probably would be doing something very physical, maybe working on houses or cutting down trees or working on an oil pipeline somewhere if I wasn't doing tech. But it's funny to think what have happened if the internet didn't arrive and what would I be doing now. But
Mhm.
honestly, at this point, no clue. So I'd probably be just a guy with a chainsaw.
Yeah, yeah. I hope you guys. I hope you're fine though with hurricane and all of that. Thanks so much for tuning in despite all of the challenges. I hope you guys are okay.
Thank you, sir. Appreciate it.
Yeah. All right. That's a wrap, and it was a fascinating conversation. I definitely enjoyed it, and I hope all of our listeners and viewers you enjoyed it.
Have
So
fun.
yeah, tune in for more like this, and I'll hopefully try to get James in a couple of months, maybe later this year, sometime early next year, to talk about a part two of this conversation. James, you're just going to say something to wind down? Were you just
Yeah,
going to?
it was a joy being here. I can't wait to
Oh,
go and talk it up in my own channels and I'm going to
yeah.
be an avid listener from now on. I really like the conversation. I actually like the cloud discussions as well. So it's a lot of fun. Thank you for having me.
All right. Thanks so much, James. All right, and we'll see all of our listeners and viewers on the next episode. Bye bye.